Okay guys, this is it. This is the last lesson of the school year, and it happens to be a really cool lesson. So I want to talk to you guys first, before we get into all this binomial expansion. I want to introduce you to something that is the coolest thing in math, and it's called Pascal's triangle. So let's look at Pascal's triangle here. We talk about Pascal's triangle in terms of rows. So this tippy top here is called the 0th row, right? Then we're getting to the first row, and notice there's a triangle of 3 ones. A 1 at the top and then 2 ones on the outside. Now, what's super cool about Pascal's triangle is if you're ever bored and there's nothing good on TV, you could just generate row after row of Pascal's triangle. So let's take a look here, and if I add 1 plus 1, I get this middle value right here, 2, right? Notice all the outside values are 1s, but look what happens if I add 1 plus 2. Do you see how I get 3? And if I add 2 plus 1, I get 3. And that's going to continue working. So I put a 1 on the outside, then I'm going to add 3 plus 1, and that's going to get me 4. 3 plus 3, which will get me 6. 3 plus 1, which will get me 4, and then my 1 on the outside. Here I would get 1 plus 4, which gives me 5. 4 plus 6, which gives me 10. 6 plus 4, which gives me 10. 4 plus 1, that gives me 5. So let's just do the 6th row, just to make sure we can generate all this. I'm going to put my little 1 on the outside. This is my 6th row. Now I'm going to do 1 plus 5, and that's going to get me 6. I'm going to do 5 plus 10, which is going to get me 15. I'm going to do 10 plus 10, which is going to get me 20. I'm going to do 10 plus 5, which is going to get me 15. 5 plus 1, which gets me 6. And then the outer one is a 1. Right? Now, what are some patterns we notice? Well, one pattern we just saw right here, right? If I add the 2 outer numbers, I get the sum is the number right below it. What else do you guys notice? Well, since you're not here, you might notice that each row has symmetry. Right, which is kind of cool. Right, we already talked about how there are 1s along the outside. 1s are the first and the last in each row. And I can add numbers in the row to get to the next row's numbers. Okay, so why do we care about this? Well, there's actually a lot of applications of Pascal's triangle, but what I'm going to show you today is binomial expansion, right? And by binomial, we mean 2 terms. We learned that last semester. So let's say I'm going to call my terms A and B. If I raise A plus B to the 0, well, anything to the 0 is 1, right? So notice that matches up with Pascal's triangle. Okay, what about my first row if I make A plus B to the first? Well, that's equal to 1A plus 1B. Look, guys. Each of the numbers in Pascal's triangle are the coefficients of each of the terms in binomial expansion. Okay, A plus B squared, I could FOIL that. That's not too bad, right? If I FOIL it, I get 1A squared plus 2AB plus 1B squared. Look, 1, 2, 1. Now, once we get higher up, we don't want to have to be multiplying out A plus B to the 3rd, to the 4th, to the 5th, to the 6th. That's really tedious. So here's where Pascal's triangle really becomes useful, right? I can take, notice here too, I can take the cube, give it to the very first term. I'm going to give all of the numbers, all of the exponents to the A. Right? And I'm going to use the first coefficient in Pascal's triangle. Then I'm going to gradually give 1 to the B each time. So here I have all of the A's have all of the exponents. Now the A is going to have 2 of them, and I'm going to give 1 to the B. Then I'm going to take another one away from A, and now the B is going to have 2. And now I've given the B all of them. So if you notice each step, I'm taking one exponent away from the A and giving it to the B. And I'm using the coefficients from Pascal's triangle in order to figure out what the coefficients of my binomial expansion are. Okay, so this is very abstract when it looks like this. So let's do a few examples. Now, there's a whole big description at the top. You know, if a positive integer, blah, blah, blah. Don't worry about that. That's just more confusing. It's just a lot easier if we do an example. So let's look at the practice problems. Okay, so what I want to do here, first I want to see that they're raising this x plus 4 to the 6th power. I don't want to have to multiply that out. So what I'm going to do is I'm going to write down the 6th row of Pascal's triangle. And we just did that up there. So what is the 6th row? It's 1, 6, 15, 20, 15, 6, and 1. Okay, so what I'm going to do here, and this is the super duper Brindley strategy, I'm going to write those numbers very far apart from each other, right below. Okay, so we're going to use just what we talked about up there. So we've got two terms here. We've got an x and we've got a 4. Now the x comes first. So what I'm going to do is I'm going to start out giving all 6 exponents to the x. So the 4 doesn't have any. Then I'm going to put a plus. Now I'm going to have, the x is going to have 5 of the exponents, and the 4 is going to get 1 of them. Right? We're gradually going to give away an exponent to the 4. Okay, then we've got a 15. Now x is going to have 4 of the exponents, and the 4 is going to get 2 of them. Now x is going to have 3 of the exponents, and the 4 is going to have 3 of the exponents. So we're gradually giving away, starting with all of them with the x, and then gradually giving them away. Now x is going to have 2, and the 4 is going to have 4. Notice they all the exponents add to 6 each time. Okay, now x is going to have 1, and the 4 is going to have 5, and then our last one is where the 4 has all 6. Okay, now is the fun part. Now we get to do the math. So let's see what we get here. Well, this one's just x to the 6th. This is 6 times x to the 5th times 4, right? 4 to the 1st. This one is 15 times x to the 4th times 4 squared, which is 16. This is 20 times x to the 3rd times 4 to the 3rd, which is 64. So some of these numbers get pretty big. This is 15 times x squared times 4 to the 4th, which is 256. This is 6 times x to the 1st times 4 to the 5th. I didn't write it down on my thing. 4 to the 5th is 1,024. And then the last one is 1 times 4 to the 6th, which is 4,096. Okay, so now let's multiply this out. So you remember when we multiply, I'm going to multiply the numbers together. So we know that 6 times 4 is 24. Right? So we have 24x to the 5th. Now I'm going to do 15 times 16. 15 times 16 is 240 x to the 4th. Now I'm going to do 20 times 64, which is 1,280 x to the 3rd. 15 times 256, is 3,840 x squared. 6 times 1024 is 6144 x, and then 4096. So that is what we would get if we did x plus 4 times x plus 4 times x plus 4 6 times. So even though that's tedious, it's worse if we had to actually multiply it all out. Okay, let's skip number 2. Let's just move over to number 3. Okay, now we've got ourselves 2 variables. We're going to do number 3 and number 4. So this is the 5th raised to the 5th power. So I'm going to do the 5th row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So again, super duper Brinley strategy, write them really far apart. Okay? So this time we have G. We're going to start out, G is our first term. We're going to start out by getting all of the exponents to the G. Right? And the 6y is going to have none of them. Okay? Then we're going to take 1 away from the G. And we're going to give 6y one of the exponents. Okay, now we're going to gradually take 1 away from the G each time. Now the pluses in between are really important. These are all mushed together into one term, but there are pluses that are between each of them. Okay, now we've got G squared, and this is 6y cubed. Now we have G, and this is 6y to the 4th. I'll move my big head in a second. And this is 6y to the 5th. Okay, so that's where we've gradually started with all of the G's, all of the exponents on the G, and then gradually taken away 1 and given it to the 6y. Okay, so here we've got ourselves G to the 5th. Here we've got 5 times G to the 4th times 6y. Here we've got 10 times G to the 3rd times 36y squared. Don't forget you have to square the 6y. Here we've got 10 times G squared times 216y to the 3rd. Sorry, I'm going to figure out what 6 to the 4th is. Here we've got 5 times G times 1,296 y to the 4th. And then the very last one we have, sorry, I did not write this all down in my notes. 1 times 7,776 y to the 5th. Okay, so now we're going to multiply all of this out. So each of these is its own little term. G to the 5th. Okay, now I'm going to multiply the 5 times the 6. So that's going to give me 30 G to the 4th y. Right, here I'm going to multiply the 10 times the 36. And that's going to give me 360 G to the 3rd y squared. Okay, now I'm going to multiply 10 times 216, and that's going to give me 2160 G squared y to the 3rd. Okay, then I'm going to multiply 5 times 1296, and I'm going to get 6480 G y to the 4th. And last but not least, I end up with 7776 y to the 5th. And that is my expansion. Okay guys, coming up is the last problem of the year. So this one's is a little harder because there's a subtraction sign here. So really what I want to think of this is 2x plus negative 5y all raised to the 6th. Okay, so let's look at row 6 in Pascal's triangle, which is 1, 6, 15, 20, 15, 6, and 1. Right? Yeah. Okay, so here I want to leave lots of room. Okay. So this one's definitely harder because these both have coefficients in front of them, the x and the y. So we're going to start out with all of the exponents with the x and none of them with the y. Okay, now I'm going to gradually take away. Now notice that negative sign there, guys. Right? It's a negative 5y that I'm putting into my formula. So I've now taken one exponent away from the 2x and given it to the negative 5y. Now I'm going to take another exponent away. And I'm going to gradually keep doing that, taking one exponent away from the x and giving it to the y. Now the 2x only has 2 of them. Okay, this is what I've got here. Okay, now this one's going to be a little bit more burdensome to multiply out. Okay, so here I have just 2x to the 6th, which is 64x to the 6th. Okay, here I've got 6 times 2x to the 5th, which is 32x to the 5th, times negative 5y. Here I have 15 times 2x to the 4th, which is 16x to the 4th, times negative 5y quantity squared, which is 25y squared. Here I've got 2x to the 3rd, which is 8x cubed, times negative 125y cubed. Right here, I've got 15 times 4x squared times 625y to the 4th. Here I've got 6 times 2x times, what's 5 to the 5th? Sorry, I wasn't. 5 to the 5th is 3125. Sorry, and that's negative 3125 y to the 5th. Sorry, I'm going to make that look a little better. Okay, and then our last one is 1 times 15,625 y to the 6th. Okay, so let's see, we're almost done. This is 64x to the 6th. This I'm going to multiply 6 times 32 times negative 5. So do you guys see here what's going to happen is this is actually going to be negative. And it's going to be negative 960 x to the 5th y. This is going to be 15 times 16 times 25, which gives me 6,000 x to the 4th y squared. Here I'm going to do 208. Oh, wait, so what am I saying? 20 times 8 times negative 125. And that's going to give me negative 20,000 x to the third, y to the third. These are huge numbers. 15 times 4 times 625 gives me 37,500 x squared y to the fourth. Here I've got 6 times 2 times negative 3,125, which gives me negative 37,500. And the last one is 1,5,625 y to the sixth. Now notice, guys, these are negatives. So actually, if I'm going to write this out thoroughly, I'm going to write 64 x to the sixth, and that's going to become minus 960 x to the fifth y plus 6,000 x to the fourth y squared minus 20,000 x cubed y cubed plus 37,500 x squared y to the fourth minus 37,500 x y to the fifth, and last but not least, that is what I've got. Phew! That is intense. So that is how I expand binomials. So this is tricky, right? So I suggest you watch this maybe a couple times just so you can really see each step. All right, guys, it's been amazing being your teacher this year. Stay in touch. Hopefully we'll be back next year in person.